It's a brief overview for Project 2 for Module 7. We're just going to cover some of the highlights and the basic concepts. And if you have questions about some of the other details, please let me know. So the overview is in this project you will apply inference methods for means to test your hypotheses about the housing sales market for a region of the United States. You will use appropriate sampling and statistical methods. You have been hired by your regional real estate company to determine if your region's housing prices and housing square footage are significantly different from those of the national market. The regional sales director has 3 questions they want to see addressed in the report. Are your housing prices in your region market higher than the national market average? Is the square footage for homes in your region different than the average square footage for homes in the national market? So right there, we're going to be running 2 hypothesis tests in this project. This one here will be a right-tailed hypothesis test where you're going to test if your sample means listing price is higher than the mean of the national average. This one is where you're testing your square footage to see if it's different than the national market's square footage, mean to square footage. That's a two-tailed test. And then for your region, what is the range of values for the 95% confidence interval of square footage for the homes in your market? So we're really, like I said, running 2 hypothesis tests and coming up with 1 confidence interval. So we're going to be looking at the same spreadsheet we've been looking at, and you're going to pick 1 region. It doesn't matter. I'm going to be looking at New England. You're more than welcome to use New England or whichever one you want. So you're going to do your introduction. Very similar to what we've been doing. What is the purpose of your analysis? What is your approach? Define a random sample. We're going to be taking a random sample of 100 observations from your region. So since we're talking about it right now, let's go ahead and quickly do that for anyone that maybe doesn't remember how to do that. So I've created this column here, random. Remember, it just equals RAND, open, close parenthesis. And what it does is it creates these random variables or numbers. So every time you generate it, it creates a new, like, see if I were to do F and change the data set, it changes the stuff. So what we're going to do is, what I like to do is go ahead and copy this so that it doesn't keep regenerating to give me a different sample if I need to redo some work. Wow, this is a lot. You know what? We're just going to go all the way up here. I didn't realize how large that was. So we're going to hit Control C. We're going to come over here and we're going to paste special. And we're going to paste values. That way it doesn't keep regenerating. So I'm going to go ahead and delete this column because I don't particularly care too much about it. That way now, if I have to come back, these are solid numbers. I don't have to worry about it being regenerated every time. All right, so let's go ahead and, oops, that's not what I meant to do, sorry. We're gonna go ahead and select this whole thing now so we can sort it. Somewhat time, but most of you guys should have done this already, but just for anyone who is having a hard time. So we're gonna do custom sort. We're gonna sort on the random. And then what we're going to do is we're going to go ahead and take those first 100. And again, it's not required to create a new sheet. I just like to. It helps me keep things a little cleaned up. I'm going to go ahead and delete that random column since I don't particularly care about it anymore. All right, so now I have a sample of 100 counties or observations from the New England region. So I'm going to say New England sample 100, just so we've got that there. All right, let's go back to our prompt. So here, for your selected sample, define 2 hypothesis questions. Again, you need to talk about this. So it says describe the population parameter for the variable you are analyzing, describe your hypothesis in your own words, and describe the inference test you will use. Identify the test statistic. Now, keep this in mind. This is your introduction for the entire report. You're going to be running 2 tests and looking at a confidence interval. So make sure you explain both of those in there and why you're doing it. And you need to use your words. So basically, it tells you up here what questions you're asking and what you're doing. You just need to explain it in here in your terms. So first, let's take a quick look at the one-tailed test. So what we're saying here is, going back up to this question up here, number 1, Are the housing prices in your regional market higher than the national national average? So let's do a couple things. Let's keep this down here for us. Let's go over here to the national market. This is one of the links in that folder. So our median, our listing price, our mean is 288,407. So when we're looking at that first test where we want to see if our listing prices are higher than the rest of the country, we have H naught, the mean is equal to, what is that, 288,407. So then our alternative, you'll see both notation with A and a 1. I'm going to put a 1 only because it's really hard to see the A on here. We want to test to see if ours is higher. Okay, so that's for the first test. That's for the one-tailed test. Let's go ahead and take a look in Excel at that one really quick. So the easiest way to do this, since we're looking at the mean, is that we can just use the data analysis package. So remember, we create that dummy variable right here so that we can go into data analysis. We're going to select t-test to sample, assuming unequal variances. And we're going to go ahead and start with the listing price. Select all 100 of those observations or counties. And then here we're going to select that dummy variable. And here for our hypothesized mean difference, we're going to use that number from our hypothesis here, 288,407. 288,407. And our alpha, I do believe, let's double check, I do believe that they said to use 95%. Yes, so we're gonna, it says that for the confidence interval, I recommend using 95%. It's a pretty common confidence or significance level. So we'll just use 0.05 and we're gonna put our output range just right up here. Yeah, right here is perfect. All right, we're gonna click OK. Now I just go ahead and delete this column. That was our dummy column that we do not care about. And we're gonna expand this just a little bit. This title doesn't mean anything since it's not accurate. Now, I'm going to go ahead and put up here listing price so that, oops, I know which variable this is because we have two variables we're going to be analyzing. So, one thing I want to point out real quick that's extremely important. Remember our nice little normal curve? Just pretend that that's a nice normal bell curve with a ton of symmetry. We are looking at a right-tailed test. So that means whatever our z value is, we're looking for the probability to the right of it. So in this case, well, actually, I'm sorry, not z value, our t value. We're looking at student t distribution. Here we have 5.57 is our t-stat. So we're looking for the area under the curve over here. All right. Now, it's important to remember that that's this output right here, this p-value. Remember, with the t distribution, we get the area to the right here. So this makes sense, right? We see a positive 5.56 and we see this over here. So another thing to remember, so here we've got a p-value that is very, 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 very small. See that e to the negative 7? That means times 10 to the negative 7. So this thing is basically 0.0000. We're just going to put that for now. That's our p-value in this example, which is definitely lower than 0.05, which is our alpha, which means that we would reject the null hypothesis. And the reason I want to talk to you a little bit about this, because look, our mean is 380,000. We want to know what the likelihood that the population mean of the New England region is greater than 288. It's pretty good. That p-value is super low. We would definitely reject the null hypothesis and conclude that the population mean for New England is much higher than the national average, which makes sense. New England's ridiculously expensive, along with other parts. You got the Pacific, which is probably also going to be higher. And New England includes New York and even where we are in Rhode Island, like the price per square foot here is extremely high. So that's the first part with the one-tailed test. Now, going through here, you're going to have to answer some questions. So here's your defining your hypotheses, your specific, your null and alternative. Summarize your data tape. So provide at least one histogram in a table. Provide summary statistics. You guys have all done this. So if you have questions about how to do a histogram or summary statistics, let me know. Talk about the sample data, describing the center, spread, and shape. When they talk about that, what we're talking about is looking at the histogram. So let's take a quick look at the histogram for that variable, for example. So let's go to data analysis, histogram, and we're just going to select that listing price variable. Oops. We're going to put it right over here next to our other. Oops, you know what I forgot to do? Sorry about that. Let me delete. We're going to go back. I forgot to check chart output. Yeah, I don't particularly care about those tables, but we notice that it's definitely right skewed, but you probably, some of these maybe don't look like outliers here, but there's definitely some stuff going on here in these very expensive areas. I'm assuming we would see New York and Boston, for example, in these areas of New England. All right. So, but the idea is to talk about this is right skewed, talk about the relationship to the mean and the median, talk about the standard deviation. Does that tell you anything about this? Is it really spread out? Is it more clustered around here at the bottom? Is that what you expected? Stuff like that. All right, so that's the data analysis. Check for conditions. Remember, you need to determine if a normal condition has been met. If it hasn't, is there something else we can look at, like maybe the size of the sample? Remember, the sample size over 30 applies here, so consider that. Determine if there's anything else. Okay, so go ahead and do your test calculations. I already showed you how to do that using the data analysis tab. Interpretation, remember the p-value and significance level. If your p-value is less than alpha, then you can reject the null hypothesis. Otherwise, if p-value is greater than or equal to alpha, do not reject the null hypothesis. All right, so here we have a two-tailed hypothesis test. So let's go ahead and set up that hypothesis looking at this sample data, just to talk about what we're looking at. Let's go back up to number 2 up here. Here we were saying, is the square footage for homes in your region different than the national or the average square footage for homes in the national market? So let's take another look. Here we're going to have H naught, our null hypothesis is going to be mean. And again, now we're looking at square footage equal to, and let's go back over to our national numbers. Here we have 1944. And then our alternative, we want to know if it's different. Not that it's less than or greater than, but different than 1944. So that means we're looking at a two-tailed test. Okay? So the way we're going to do that is very similar. We're going to go into that data analysis tab. I'm going to scroll down a little bit just so I can see a little bit. All right, data analysis. And we go down to t-test unequal variances. And instead of looking at that D column, we're actually going to look at the F column. Here's our square footage right here. So instead of highlighting, I'm just going to put F and F because the rows are staying the same. And our variable 2, that dummy variable, is the same. Our hypothesized mean difference now is 1944. We're going to keep the same alpha. Our output range, we're going to move it down here. And we're going to click OK. So we're going to clean this up a little bit, just make sure we're looking at the right stuff. So we're going to delete this. Shift cells to the left. And this variable now is square footage. All right. So now we have our two-tailed hypothesis test where it's a p-value of 0.148. Now, let's look at that. Oops. So our new p-value in this example is equal to, what did I say, 0.148? 0.148, which is definitely bigger than 0.05. So we would not reject the null hypothesis in this one. And let's take a look. Our mean for our sample is 1901. The sample we're testing is 1944. Those are pretty close.